I am Aditya Mehrotra here with Christian Jiang. I hope you're all doing fine. We are from the Mobile Robotics Group at EPFL, and today we'll be presenting a paper-based programming language for computing education in classrooms. Yeah. Tangible programming platforms are where physical objects can be grouped together to control either virtual agents or educational robots. They provide a physical aspect to abstract concepts and have proven to be more engaging and provide a playful way of learning to students. They can also be helpful in implementing social constructivist approaches, since students usually work in small groups and collaborate to make programs and are actively participating in it as compared to traditional lectures. However, these platforms have not been widely adopted in classrooms yet. We suspect that this could be due to the expensive nature of the setups and acquiring, maintaining, and setting them up. So a paper-based model or platform is quite intuitive, since paper is inexpensive and a ubiquitous material in classrooms, as well as it's quite easy to produce. So we developed PayPL, a paper-based programming language platform for making tangible programming more accessible to classrooms. On the right, you see the process of identifying the tiles. So basically, the physical tiles are assembled in a sequence and an image of it is taken. The image is then rectified and each individual tile from the sequence is identified from a predefined library. They then form a chain of commands which can be used to control either a virtual agent or the robot. This is done with the help of the OpenCV library for Python. We adopted two camera configurations for the platform. The first one being the mirror configuration, which with a handy mirror can be clamped onto the webcam of a laptop, and it projects the image of the objects in front of the screen. The other one being with a webcam, where the webcam has to be manually pointed to the objects, but it allows more spatial freedom. This was done to simulate the use of a tablet. The platform we first developed for Timio educational robot. On the right, you see that it follows an event-based programming language. The orange tiles are events, and the blue tiles are the actions that can be performed by the robot. So with this platform, we conducted two studies. First, with a set of high school students. In this study, we wanted to explore multiple variables. First one being, how does the group size affect the performance of the groups? So this was either a 3-membered group or a 2-membered group. The next one being the effects of the camera configuration on group dynamics, that is with the mirror configuration or the external webcam configuration. The third one was a limitation on access to the tiles. So the groups were either allowed to have free access to all tiles or had equal number of tiles distributed amongst the members, which they could use only the one, where they could use only the ones they held in possession to program the robot. This was done over a course of 2 days in 6 sessions lasting 30 minutes each. And we saw a participation of over 100 students. So here is a typical setup. The students here are using an external webcam with free access to the tiles, and there are 3 members in the group. So it forms a cam-free G3 condition. They're performing the line following task with Timio. So on the right, you see all the 8 conditions of the experiment, and students had to perform 6 tasks throughout the experiment. And we were observing the groups for 3 variables. The first one being whether or not they're able to complete all tasks in the limited amount of time. Second one is the number of errors committed by them throughout this process. And third one being the amount of time spent actively discussing about the tasks at hand. As a result, we found that triads were more successful in completing all tasks as compared to dyads, where only half of them were able to do so. And when comparing the camera configuration, we found that the mirror configuration was more suitable for completing the tasks for triads as well as dyads as compared to the camera configuration. When coming to the discussion state, that is the amount of time spent discussing, the limited conditions had high amount of time of discussion and also less variance in this recorded data as compared to the free condition, where there was more variance, and which suggests that their behavior was more unpredictable. Now, coming on to the errors in the programs loaded by them, it was observed that overall triads tended to commit lesser errors than dyads, and also certain kind of errors were only observed in the dyad condition as compared to triads. Now, the second study was with middle school students, which would be considered the ideal target audience for this platform. Here, we wanted to explore the intuitiveness of the platform for beginners and also its ability to help teachers in orchestrating the class as compared to when they use a graphical interface. So in a 1-hour session, we had 30 students from 2 different classes and their respective teachers. And later on, we also conducted interviews with the teachers. So the students were first presented the robot and introduced to it. They had about 20 minutes to explore its functionalities, and then were asked to solve the Parsons puzzle. Class A was presented the puzzle with the PPL tiles, and Class B was presented with the VPL tiles. That is the graphical version of programming the robot. And then they were given a set of tasks which they had to perform with the robot and solve the puzzles again. As a result, we found the Class A who were using the PPL platform achieved higher scores, and then once doing the activity, they went on to achieve a perfect score, everyone. As compared to Class B, who were using the VPL platform, had variance in their scores, and although improving a bit, could not achieve perfect scores, which would be ideal. Then, in the following session, the students switched their platforms. That is, Class A went from PPL to VPL, and Class B went from VPL to PPL. In these sessions, we track the activity of the teachers. So teacher A with the PPL platform had spent time addressing each group at least once, and half of it monitoring the overall progress of the class. When switching to VPL platform, however, they spend the time addressing only 2 groups at a time during the session, and the amount of time spent monitoring also decreased. A similar trend was observed for teacher B, who spent most of their time with 2 particular groups, and only a fraction in monitoring the overall progress of the class. When switching to the PayPL platform, however, they were able to address all the groups at least once, and were also able to spend more time monitoring the class. So in conclusion, from the first study, we found that triads were more successful in completion of difficult tasks as compared to dyads, and they also committed fewer errors. This could be, there could be that a group of 3 members provides better scrutiny of the programs loaded as compared to a group of 2. Now, when considering the limitations on use, it could have an influence on the way a group collaborates and on individual self-reflection. And this could also be interesting for introverted participants who are not usually as engaged in such activities. The system configuration also may have an influence on the group dynamics and should be considered when designing such activities. From the middle school study, we found that the system had high amount of intuitiveness for beginners, and the PPL platform also was able to help teachers orchestrate the class better as compared to the graphical interface. Teachers in their interviews agreed to the potential of PPL, that it could be a good way of introducing programming to beginners, since it might provide a way of having a better foundation for moving on to other platforms, more complex platforms later on. However, further studies have to be performed to draw substantial conclusions about these studies. Our current work focuses more on expanding the accessibility factor of the platform. So we developed the framework for an Android app as well, and also developed a cardboard-based educational robot. And we invite you to follow our research to find out more. We're open to questions now, so if you have any, please do ask.